Okay, so this video is to focus on how to solve multi-step equations with one variable, linear, and specifically with fractions, okay? So it's focusing specifically on how to deal with when there are fractions in a problem. Now, there are multiple ways to do this, but if you are feeling uncomfortable with fractions, then one way to deal with this is specifically to get rid of the fractions from the very, very get-go, all right? So step one of solving any equation is to simplify if needed. And if you're not feeling very friendly with fractions, then you're going to find it necessary and very needed to get rid of those fractions. So I'm going to kind of expand on step one specifically for fractions. So to get rid of fractions, part A of that step, so the first thing you're going to do is you're going to need to find the common denominator. We call that an LCD for the least common denominator. I'll just write it out once real quick in case it helps make an LCD more understandable. That means I'm going to take a look at every single denominator in the problem. And I'm going to look for a number that all of these four numbers can multiply to. All right. So by brute force, I would take the bigger number, like 3. So in this case, 3 is the biggest denominator. And I'm going to see, can all of them multiply to 3? Nope, 2 doesn't multiply to 3. So that's not going to work. So then I would try the next multiple of 3. So 3 doesn't work, so 3 times 2 equals 6. And I would see, well, does 2 multiply to 6? Yep, it does. And 3 multiplies to 6 because I picked it straight from 3. And then these two are the same as the first two numbers. If that didn't work, then I would just try the next multiple of 3, which 3 times 3 equals 9. But it does. So 6 is my LCD. That's the number I'm going to stick with. So let's clean that up so it's not so messy looking. So the least common denominator that we found was 6. And then we're going to multiply both sides of the equation by 6. And our goal here to get rid of the fractions. All right, so let's see how that's going to happen. So I'm going to just rewrite the original equation down here. I'm spacing it out, and you'll see why in a second. And I'm going to multiply both sides of that equation by the LCD of 6. So I'm multiplying the left side by 6, and I'm multiplying the right side by 6. So that means that I'm making this side bigger by 6, and I'm also making this side of the equation bigger by 6. So that's allowed. I can do that. I'm keeping the equation equal. And I'm just going to distribute the 6. So it's going to be x over 2 times 6, and 1 over 3 times 6, and then x over 3 times 6, and 1/2 times 6. Now 6 is the same thing as 6 over 1, and it's kind of easier for me to multiply fraction by fraction, so I'm just going to change all these to 6 over 1. But 6 over 1 and 6 are the same number, okay? And then I'm going to cancel out all the denominators before I do anything else, because my goal is to get rid of all the denominators, because that's what makes a fraction a fraction. So I'm going to cancel this out and make that a 3 and that a 1. So that's 3x over 1, or just 3x. Because remember, anything over 1 is just itself. This cancels out, that becomes a 2 and 1. So 2 times 1 is 2. Here, that cancels out with a 6 and becomes a 2. So 2 times x is 2x. This cancels out, becomes a 3, and that becomes 1 times 3, which is plus 3. No more fractions. This looks a lot friendlier already. Okay? So again, to simplify fractions, the first thing you're going to do is find an LCD, which is the common denominator between 2 and 3, which was 6, and then multiply both sides of the equation by that 6, and you're going to end up, if you pick the correct LCD, you're going to end up canceling all the denominators, no more denominators. Very nice. Step 2. If there are variables on both sides of the equation, so check it out and see if there are. And indeed there are, because there's a 3x here and there's a 2x, so there's variables on both sides. That's a problem. Then get rid of the variables on one side, so choose one of the variables. So we're going to choose the 2x, we're going to get rid of that one by adding or subtracting it. Okay, so we're going to do that. We're going to get rid of the 2x by adding or subtracting it. So, I ended up accidentally erasing something. Let's put that back up there. That was 2x plus 30. All right, so I'm going get rid of this positive 2x by doing the inverse operation, which is negative 2x, subtracting it. That cancels on this side, and I get what? 1x plus 2 equals 3. And now I have a normal equation with just one variable, which was my goal for step 2. Step 3, isolate the variable by using inverse operations. You will need to use SADMEP order. So this assumes that you've already reviewed and refreshed yourself on solving on these equations. To get rid of to isolate x, I have to get rid of plus 2. The opposite of plus 2 is minus 2. So x equals 1. There's my answer. Let's do another example. You might want to pause the video and try this on your own. I highly recommend it, if you can. If not, I'm here to help you. All right, so step 1 is to simplify if needed. And again, if you're not friendly with fractions, the first thing is going to be to get rid of the fractions. So I'm going to find an LCD between all the denominators, which are 3 and 9. So again, if you're not sure how to get a common denominator, pick the bigger one and see if it works. So I'm going to pick the 9, and 3 multiplies to 9, and 9 is itself, so that works. So my LCD in this case is 9. So my LCD is no longer 6. That was the last problem. It's now 9. Step B for simplifying is multiply both sides of the equation by the LCD to get rid of the fractions. So we're going to do that. So I'm going to first copy that equation down. So I'm going to multiply this side of the equation by 9, and I'm also going to multiply this side of the equation by 9. I'm just going to distribute that. Now, I'm actually just going to multiply it to the 2/3 because this is really, when I multiply that 9 to the left-hand side, it's the same thing as doing 9 times 2/3 times x plus 5. So if I multiply it to the 2/3 and I multiply it to the x plus 5, I'm actually multiplying by 9 twice, and I'm not allowed to do that because I'm only multiplying by 9 once on the other side. So you can only multiply by 9 once on each side. So you can either choose to multiply it to the 2/3, or you can choose to multiply it to the x plus 5, but that's harder, so I'm not going to do that. I don't want to do that. So you only multiply the 9 once on each side of the equation, okay? So if there's a parentheses and a number in front of the parentheses, you can only multiply the 9 by one of those because you're multiplying 9 times 2/3 times x plus 5, so that's 3 things. And so the 9 only goes to the 2/3 and not to the x plus 5 in that case, okay? Otherwise, you're multiplying by 9 twice. So I'm going to write that out here only once. So 9/1 times 2/3, because remember, 9 is the same thing as 9/1. Same thing on this side. I'm only going to distribute it to the 4/9 because that's all that's there. So that I'm going to write this times 9, which is again the same thing as 9/1. So my goal is to get rid of the fraction, so I'm going to cancel out the denominator here. So 3 and 9 cancel to 3 and a 1. 3 times 2 is 6/1, or just 6. 9 and 9 cancel out, and it becomes 4. All right. Simplify if needed. So I also need to simplify the 6 to the 6x. And 6 times 7 is 30. Step 2. If there are variables on both sides of the equation, well, in this case, there aren't. So I can skip step 2. If there are not variables on both sides of the equation, you don't have to do step 2. So I'm done. No step 2. And I'm going to go straight to step 3, which is to isolate the variable and solve like a normal equation. So remember that to solve for 6x plus 30, you have to get rid of the plus 30 first, because by SADMEP order, you get rid of anything that's subtracted or added to the x first. So the plus 30's subtracted or added, so I'm going to have to get rid of that first. And then I've done the subtraction and addition. I get rid of the 30. I get 6x equals negative 26. If you do that on a calculator, 4 minus 30 is negative 26. Then I get rid of anything that's multiplied or divided to the x, so that's 6 times x. I'm going to divide both sides by x, 6. And then if you do it on your calculator, you should get negative 13 thirds. Or negative 4 and a third. Either way is okay. The thing to be careful of is if you do it as a decimal. If you write negative 4.3, that is not exactly correct, so you'll get a partial credit. You can write a 4.3 with a bar over it. That is allowed, although it's a little bit unusual. All right, let's do another example. Oh, I do not want that SADMEP to be so let's see if I can erase that too. All right, let's again do a different kind of problem. So let's do 2x plus 4 over 3x minus 1 equals 1/2, because that's a little different. Okay. You might need a little help on this one to start with, because the least common denominator in this case is a little bit, it's not just a number. 3x minus 1 counts as one factor, all right? You cannot separate the 3x from the minus 1. 3x minus 1 counts as one factor. There's 2 reasons for this. One is because whenever there's an adding or subtracting in there, I can't actually factor this answer. 3x minus 1 is a number. I don't know what that number is, all right? But if it were just like 14, I could split it to 7 times 2, right? But if it's 3x minus 1, I can't just split it because I don't know what 3x minus 1 is yet. So if it's a adding or subtracting problem, I have to keep the whole problem together. Another way to think of it that might be a little simpler is 3x minus 1 is in parentheses, all right? And there's nothing I can factor out of it. So anytime something is in parentheses and there's nothing you can factor out of it, the whole parentheses counts as one factor. Anytime there's adding or subtracting, that's going to be, it's probably going to be true, all right? So we're going to keep that for now. Until later when you learn how to factor things that are added and subtracted. So this is one factor and the 2 is the other factor. So the least common denominator in this case, because I can't really find something that's going to multiply to 2 from here or vice versa, has to have a factor of 2 in it, and it has to have a factor of 3x minus 1. The common denominator has to have both factors from both denominators. Or you can think of it as it has to be a number that the 2 can multiply to, and it has to be a number that 3x minus 1 can multiply to. So if I just multiply them together, then I'm for sure going to get a common denominator. So if there's a number and a expression, a factor that's has adding or subtracting in it, you just multiply the 2 together to get the common denominator. For now. All right, we're going to multiply both sides of the equation by that LCD to get rid of the fractions. That part stays the same, all right? So I'm going to rewrite this same exact equation, spaced out. And again, I'm going to multiply both sides of the equation by the LCD, which is 2 times 3x minus 1 on this side, and 2 times 3x minus 1 on this side. So I'm going to write that down here, times 2 times 3x minus 1, times 2 times 3x minus 1. And remember, anything is just itself over 1, so if you just want to put that over 1, just to make it clear that it goes to the top of the fraction, that's fine. So remember that it only cancels if the entire factor is the same. So 3x minus 1 and 3x minus 1 are the same, so that cancels out. And then I'm left with 2 times 2x plus 4. Don't forget that the 2x plus 4 also has invisible parentheses. So that's going to become 4x plus 8 if I distribute that. Same thing here. I'm going to see what cancels out on the side. Oh, I did not want it to do that. So let's try that again. All right, so this 2 and this 2 are going to cancel out, and I'm going to be left with 3x minus 1. All right. Step 2, if there are variables on both sides of the equation, so check here if there are, and this is a good time to pause the video and do the rest of the problem on your own. Okay. So if you notice that there are variables on both sides of the equation, you need to get rid of one of them. So I'm going to get rid of the 3x by subtracting on both sides. Subtract 3x on both sides. That cancels out. That becomes x plus 8 equals -1. And now I have a variable with only an equation with only one variable in it on the left. That's what I wanted. Solve for x. I'm now going to isolate x by just subtracting 8 from both sides. You do -1 minus 8 on your calculator, you'll get x equals -9. Hopefully that is enough to get you started with review. And this should be just a review. So it should be a good enough review for you to kind of remember how to deal with fractions and do some practice problems.